All right, lovelies, here is grade 7, module 2, lesson 2. Our I can statement is that I can calculate markups and markdowns. So lots of vocab in this lesson. We have a markup is the amount of increase in a price. And then we have our retail price. That is the amount an item is sold for after a company adds a markup to the original price. So in this down here, we're going to see what that formula looks like for adding a markup plus the original cost. And then we have our discount. So that's the one where our price goes down. They have a markdown of the amount a price is decreased to get an item to sell. So a markup where they're increasing the price. Maybe they bought it from a manufacturer and they're selling it as a markup or at a markup so that a store makes money off of that. Or maybe there's an item that has been struggling to sell, so they're going to decrease an item in order to sell it. And that is our discount. What we have in our box here is a couple formulas. We have our markup. That is when we take our retail price minus our original cost. So our retail price minus our original cost. And then we take that amount and we put it into our percent markup. So this goes in our numerator. This will most of the time get us a decimal. Just a reminder from the previous lesson that when you have a decimal and you're needing to change it to a percent, that you move our decimal over twice. Percent markup is expressed as a percent, so you need to be able to move that decimal over twice to get the correct answer. The same setup for a markdown or a discount. You're going to do your original price minus your sale price, and then you're going to take that dollar markdown, put that in your numerator, and again over your original price. And same thing, we are expressing that as a percent. All right, so we have the expression, so reading through this paragraph here, the expression KX represents the amount of a markup or markdown where X is the original cost. So X is paying 100% one of the original cost. And that's before a markup, before a discount. And then K is that rate, that percent of a markup or a markdown. So the best way to calculate that retail price is by adding KX to the original cost. So again, we said that's 1. They're paying 1 whole, 1%, 1x, and then whatever our percent markup is times that original cost. We would add those together for our retail price, and then our discounted price would be subtracting them, because you're going to take your original, your full cost here, and then take off your 40%. Take off whatever that discount is. So here we have a shirt, and it costs the store $16 to buy it. The store is buying it from a manufacturer. The store sells that shirt for $36 to a customer. We want to know what is the percent markup of the shirt, and then what equation can we use to find the retail price of an item, so a different item, with the same percent markup. So we have two different questions here. We first need to find the percent markup of the shirt, and then we need to write our equation so that we could plug in for another shirt at maybe a different cost, but it's going to have that same percent markup. So our first step here is we need to find the dollar markup of the shirt. We're going off our formula up here. find the dollar markup of the shirt. So we're going to need to do some subtraction. So we're taking our retail price minus our original cost. So our 36 minus our $16 that they bought it at from the manufacturer. And then we need to take those $20 and put it over our original price, our original cost, what they bought it from the manufacturer at. When we do that division, we are going to get a decimal. And then can you change that into a percent? What is 1 25/100ths as a percent? We need to move our decimal over to the right twice. Don't forget your percent sign. We would have 125%. So big percent increase on this particular shirt compared to that manufacturer price, that original cost. Now we need to write an equation using the percent markup to relate the retail price, Y, to the original cost. So here we're going to have Y equals our original, so X, and then we need to add in our 1.25x. That's our markup percentage. Okay, we're going to add our original plus our markup. And we add those together. Our coefficient here, if nothing is written in front of our x, it's a 1. A 1x plus 1.25x will equal 2.25x, 2 25/100ths x. So we would have our equation that we could plug in if we wanted to. Say there were some pants that they wanted to mark up at that same percentage, you could plug in your cost here and get your new retail price. Okay, so writing this formula allows you to find, with that same markup percent, what a retail price would be for another item.